Okay guys, so today we're going to go ahead and continue from yesterday's lesson, which was lesson 8-9, solving equations. We're going to go ahead and continue. Today is going to be part 2, and I'm still literally just going to go straight into the examples to save some time in this video. So we're going to go ahead and we're going to solve the given equation 4x to the power of 2/3 minus 5 equals to 11. So still going to continue with the same steps from yesterday. We're going to solve this using SWBAT. So do I have subtraction? Yes, I do. So I'm going to go ahead and add the 5. So we're going to get 4x to the power of 2/3 equals to 11 plus 5 is 16. So addition, no. Division, no. Multiplication, yes, we do. So we're going to go ahead and so the multiplication part is right here between this 4 and this x. So these two are being multiplied, so there's the multiplication is happening. So how do we get rid of multiplication? We divide. What I do to one side, I do to the other. So now this cancels out, leaving me with x to the power of 2/3, and then 16 divided by 4 is going to be 4. So now we're going to go ahead and we're going to continue. Do I have an exponent? Yes, I do. So now here, I want to get rid of this 2/3. So once again, just like yesterday, we do the reciprocal, which is 3/2. And what I do to one side, I do to the other. Now these right here cancel out, leaving me with x is going to equal 4 to the power of 3/2. Now, what I'm going to do here, okay, is that I'm actually going to convert it to radical form, because I'm not going to really be able to evaluate 4 to the power of 3/2. So I'm going to go ahead and convert this to radical form, where the denominator is the index. So that means that I'm going to get x equals 4 square root of 4 to the power of 3. Okay? Now there's a different way to write it, or I can say I'm going to get the square root of 4, and then all I'm going to do is put the parentheses on the exponent on the outside. So now that means that you have to evaluate whatever's on the inside first, and then you can evaluate the exponent. So in this situation, I'm going to ask myself, okay, well, what's the square root of 4? Well, the square root of 4 is 2. Okay, and now I'm going to go ahead and raise this to the power of 3, because this right here is going to come second. Well, what's 2 to the power of 3? Well, 2 to the power of 3 is going to be 2 times 2 times 2. What's 2 times 2? 4 times 2 is going to be 8. So what's my answer here? X is going to equal 2 plus or minus 8. Now we're going to go ahead and look at example number 4. Divide this up right here. So for example number 4, we're going to have x minus 3 to the power of 2/5 equals to 4x to the power of 1/5. Okay, so now if you look at this, we have 2 radicals on one side and the other side. But the one thing that I do notice is that they both have a denominator of 5. So if I look at this 1/5 and I multiply it by 5, well, 1/5 divided by 5 is literally just going to be, 1/5 multiplied times 5 will literally just give me 1, right? So what we're going to do here is we're going to go ahead and we're going to get this equation and multiply it times the denominator, since they both share literally the same denominator. So I'm just going to rewrite it here again. And now I'm going to go ahead and I'm going to multiply by the denominator on both sides, which is 5. And so now these two have to get multiplied together. So 2 over 5 times 5, you just multiply times the numerator. 2 times 5 is 10. Divided by 5 is going to be 2. So that means that here we're going to end up with x minus 3 to the power of 2. And over here, you're going to end up with 1 over 5 times 5. Multiply that times the numerator, it's just 5 divided by 5, which is literally just 1. So that's just going to be 4x. So there's no need for me to put a power of 1. If you want to, you can, but it's literally just a 1. So now we're going to go ahead and continue. So now here I have x minus 3 to the power of 2, meaning that I have 2x minus 3. So I'm going to do x minus 3 times x minus 3 equals to 4x. I'm going to go ahead and do the distributive property. X squared minus 3x minus 3x plus 9, because a negative times a negative is a positive. That equals to 4x. Combine like terms. X squared minus 6x, oops, plus 9 equals to 4x. Okay, now I want to make sure that this equation is equal to 0. So the easiest thing for me to do would be to get whatever's on the right side and then move it over here to the left side, than any other way around, right? So that means that I would have to try to get rid of this 4x, so that way my equation can equal to 0. So that way you can solve this using tic-tac-toe or the tabular method. So I'm going to go ahead and I'm going to subtract this 4x, and I'm going to subtract it with the 6x because those are the ones with matching variable and exponent. Therefore, that cancels out, leaving me with x squared. Negative 6 minus 4 is going to be negative 10x plus 9 equals to 0. So now we have to go ahead and do tic-tac-toe or the tabular method. We'll go ahead and do this one. So the x squared always goes in the first box. The plus 9 goes in the last one. So we have to go ahead and get a plus 9, but they need to add to a negative 10x. So I would say that's probably going to be 9 times 1. This number has to be positive, but this number over here on the left side has to be negative. So I'll say a negative times a negative equals a positive 9, but negative 9 minus 1 is going to be negative 10. So I get a negative 9x and a negative 1x. X times x, negative 9, negative 1. So these right here are going to be my factors. So I'm going to get x minus 1 times x minus 9 equals to 0. Set these equal to 0. Plus 1. X equals to 1 plus 9. X equals to 9. And that right there are going to be my answers. X equals to 9. X equals to 1. And then over here, this was also my answer. Okay. So just a clarification, I don't know, maybe like an explanation to all this. So basically, example number 3 is when you have a rational exponent. On one side. So that's what we had here. This was on one side. And then over here, example number 4 is when you have a rational exponent on both sides. All right, so I had this here and then I had this here. So just a heads up on that. So now we're going to go ahead and move on to the next example. So we're going to go ahead and we are going to start with example number 5. So we are going to solve x minus 5 to the power of 1/5 being greater than 10. So now if you look at this right here is going to be an inequality problem because we have the little Pac-Man sign. Okay, so what are we going to do? We're still going to go ahead and we're going to solve this using SWBAT. Okay, do I have subtraction? Yes, I do, but it's inside the parentheses, so I'm going to move on. Addition, no. Division, no. Multiplication, yes. Where's this multiplication happening? Right here between 5 and the parentheses, okay? So I'm going to go ahead and divide 5. What I do to one side, I do to the other. So now I'm going to get x minus 5 to the power of a fifth is greater than 10 divided by 5, 2. So now we continue. Do I have an exponent? Yes, I do. The exponent right here is 1/5. So I'm going to go ahead and I am going to raise this to the power of the reciprocal, which is just 5/1. And 5 divided by 1 is literally just 5. These two cancel out, leaving me with x minus 5 is greater than 2 to the power of 5 means 2 times 2 times 2 times 2 times 2. Well, what's 2 times 2? 4 times 2 is 8 times 2 is 16 times 2 is 32. So I'm going to get x minus 5 is greater than 32. Okay, so now do I have parentheses? No. Subtraction? Yes. Add the 5 to the other side. Now x has to be greater than 37. And that right there is your answer. And that is all I have for you guys today. Make sure to do the homework. It's going to be similar to all of these examples. If you have any questions, just make sure to ask me. Other than that, have a good day.